thank you everyone for joining. So Ethan Roth from UAF has put together a session with multiple presenters for launch and recovery systems. So with that, I'll let him take it away.
Thanks, Lee. I'm just going to provide an introduction and kind of moderate a little bit. So this will be on launch and recovery systems, which we also call LARS. The focus is going to be on hands-free systems. So these are systems that, preclude the need for taglines. That's because at the end of the boom or the crane, there's some sort of docking head mechanism. And we're either using the tension member, or we're also going to talk about latching mechanisms today as solutions for holding packages in docking heads. So Brandy's going to start off talking to us about summarizing a meeting that we had in July. That sort of provides the motivation for why we're having this session this morning. And then after Brandy, we're going to hear from Harsen Kocan from Macgregor Triplex. He'll talk about the LARS that is being built or has been built for the new RCRVs. So that'll be interesting to hear about. And then we'll hear from Fred Denton, who's with the WHOI Jason ROV group, who works extensively with their LARS system. So I thought it'd be good to get some different perspectives so we can come up with some ideas and solutions for what the operators are looking at in the future. So with that, I'll hand it over to Brandy.
Thank you, Ethan. As Ethan mentioned, we had a meeting in July with participants, including a combination of crews, tech managers, and technicians from institutions that have some of these auto-rendering launch and recovery systems, with the goal of determining if we were having consistent issues, if there was a recurring theme, and if there were perhaps tools that would benefit the community and users of those systems. I'm writing a report right now. It's stuck in the editing phase. I'm not good at that, so it's just going to be a minute. But some of the takeaways that I wanted to share with you was that we saw consistently, we're seeing increased tension at the end of the wires at the termination because of the nature of the docking and then using tensiometers to determine, if the package is in place. So it's seeing more tension at the termination than traditional systems have in the past. There have been a couple of ways that folks have mitigated them that might make a good best practice document perhaps in the future, one of which is all stops when it doesn't operate as expected so that you can figure out where it's at. And then also custom tension limits for different packages, depending on your system. The ease of setting that might be different, but it can prevent you from having more tension than necessary. We've also talked about locking mechanisms to prevent the loss of packages and cable parting. And perhaps there's a future in development of something like that. And we also touched on the idea of an advisory body to help people with these things, especially since everybody has a little bit of a different system. Now, the group that met in July to talk about it, once I finish editing this report, are going to meet again to see how we should proceed and if there's anything that we could produce that would benefit the community using these systems and in the future utilizing these systems as they become more popular in the fleet. So that was what I had. Also, I expect this to be a very active session. And so if questions or discussion runs long, there is a community tab for launch and recovery systems.
Okay, thanks, Brandy. Harsen, do you want to share your screen and give your talk?
Yeah, can you see my screen?
Yes.
I'm just gonna run it in full or slideshow. So you're only seeing the PowerPoint, right? You don't see yourself. Yeah.
It's in presentation mode.
Yeah, I'm just sharing the presentation, not the screen. So, yeah. Anyway, just a short introduction. My name is Harsen Kocan, and I'm a design engineer in Macgregor Triplex, former Triplex. Been working with different research lifting appliances for almost 11 years now, and started back in 2010. My first project was Sikuliak. So I'm really honored to be invited here by Ethan. So what I'm going to present here, it is the integrated CTD LARS system, the system that we have developed Triplex together with Roth. Last night, my colleague Finn have made an introduction about this whole joint venture before, and now we are basically one company. So actually, I will take one example. The example that I'm going to take for the mechanism of the docking head is based on the last CTD David or the LARS system that we delivered to RCRV. The first vessel we have delivered already, and the next two vessels we have ready for shipment. So here, for basically all of these systems that I will present now here are working in more or less the same way. It can be a davit, it can be an overhead crane, but the principle of the docking head, it is the same. The docking head and the winch are working together. Just a short introduction on the system itself. The system consists of like a parallel arm linkage mechanism with a telescopic boom, and we have a double sheave guiding unit with a main block, which is also pivoting block, and the docking head, which is not connected to the pivoting block itself. This is an improvement we have made on Sikuliak. This docking head is connected to the sheave itself, and that we had some trouble with the side pull, so we decided to split these two. And we also have I will on the right on the 3D illustration on the right side, you can see also this red cylinder. So in principle, what the cylinder is used for, we have when we start lifting off from the inboard position, the cylinder is set to a bypass mode. So there is a small damping due to the small fitting sizes on the oil flow, and we have the cylinder free for movement. So when we lift the rosette in the inboard position, and then we take the rosette out, so from inboard to cast, and from cast all the way down to deployment position, where we are close to water level, so about a meter with the docking head. So that means that the CTD rosette is already in the water. And from this position, well, eventually we will go back to cast when we want to do the cast. And in cast position, we use the cylinder to lift the docking head up in order to prevent the rope to swing inside the rollers in the docking head, and to leave the sheave for free swiveling. We can see it more described here. The sheave, it is balanced, so it means when we lift the docking head up, the cylinder and the rope can freely move around. I will also show this later in the one simulation or an animation that we have here. The principle of the safety for having the termination safe and the rope connection safe, or the cable safe, is that on the docking head itself we have two sensors, and these two sensors are being activated by the bolt. On the docking head we have 6 springs with the stainless bolt, and these bolts are running in composite bearings. So the sensors that we have placed is basically, first sensor is the half compression of the spring, and the second sensor is, well, almost a full compression of the spring. The idea behind the sensors and the control system on the winch is that we want to make sure that the winch is always in a tension that is between the full, the spring being fully uncompressed and spring being half compressed. So we don't want to go between half compressed and full compressed. In that area is something that we don't want to go. So what we do is that in our human interface or the human machine interface on the system that we have in our Pentagon system for the controls of the winches, we are setting up a value of load with a bit more increased due to the springs, and this is done normally during the commissioning. So this setup of the load, and also the sensors that we have. So we are having a preset load in the control system, and when we activate the first sensor, the load will be in case that happens because of the dynamic motions. When the first sensor is activated, the load of the winch will be reduced for a percentage that we set up in the control system. So it can be, for example, 20% less than what we have preliminary set up or set up at the beginning for the constant tension feature. So that is the principle, and the sensor 2 stops the winch completely, the holding in on the winch. How the system works is that actually when the system is in constant mode, in this constant tension mode, we are moving the crane, and by doing that, the springs are compressing the load and creating the tension that the winch, and make the winch pay out. So as we move or stop with the crane, the winch will follow. And eventually, if there are higher sea states, when we have when we have like 10 centimeters of movement on the spring, the winch will pay out more than it should. So that is the principle of this system. And what is good here is that we have the integrated controls with David and the winch. So that means that at any point, if we want to pay out winch manually, we can do that from the same place. As you can see on my presentation here, the two left joysticks are the David. One is for tilt, the other one is for telescope. And then we have the middle is the winch. And the screen where we can see the load, the tension readout, the speed, and the payout length. The right joystick is the lifting of the docking head. So yeah, this is the principle that we have for the docking heads that we are delivering in, let's say, 90% of the cases. I have also prepared, next to this one, I have also prepared one more solution that we have, but maybe we should first have a look at, this is taken out of the simulator that we also have delivered to OSU for the, yeah, actually we can control any equipment of the vessel. If you would like, I have the simulator. I can only show it. Fortunately, we cannot share it. But I have created a video with the system in action. So I'm just gonna play it here. It's a 4-minute video, I think. And now we are selecting. Okay, I'm gonna talk you through this. Here we have the tension button on the right side of the winch, and you will see that being selected when the rosette is in contact with the docking head. So now we are only moving the CTD davit. Yeah, and the docking head doesn't have a swing in heel direction, so it's only in roll. Yeah, so we are fully out with the tilt. The sea state in this simulator, I think it's not set up at all. We have also this option that we can change to have a bigger sea state, but here I think it's normally like 2 on the default. So we are telescoping, lowering the rosette. It's already in the water. Yeah, and you can see here the readout on the docking head. Actually, the simulator gives a real readout. So here I just have made a fast drive with the winch. So in principle, the docking head is being lifted in recovery, in deployment position, and then we are safe to lift up the davit in cast position. You can just maybe, and then we are ready to cast. In principle, the same goes with the recovery. When the CTD rosette is in the or almost close to the surface, we are lowering the docking head to make sure that the rope doesn't go away. Also inside the docking head, we have some rollers to prevent the damage of the cable against the construction of the docking head edges. But the whole idea with lifting the docking head is to avoid touching these rollers, because the cable is, the rollers are small against the cable, so that's not really good. Yeah. Yeah, and then we are back. And here, this is also a package movement system that we create or made specially for OSU. It was a new product for us. So in principle, we have also handling of rosette on board, where we are moving with a pallet and a chain system inside the hangar. Okay, this was the video. And now I would like to present also another concept that we have. We have delivered this to a vessel called Kaimei in Japan, owned by Gemstech. And this system is based on a latching mechanism. We have 3 latches with on the docking head. Here on this photo, we can see the latches. So we have latches that are released by the cylinder, and they are made in a fail-safe way. So, yeah, sorry, I skipped one thing, and it's very important. The frame that is, or the plate that is being lashed is attached to the CTD frame. So we are not attaching anything to the termination or the bullet. The rope itself doesn't have any influence on this latching. So the latching plate, the latching part is connected to the CTD frame. We have this jaws, and the plate, when it depends on if we want to deploy it or recover it, it's lifting the jaws by the geometrical shape, and in that way we don't need the cylinders in order to lock it. We are using the cylinders only to unlock the mechanism. This system also has multiple sensors for stopping the winch or indicating when the latch is, if all 3 latches are safely closed or if something is wrong. So it's a good system for winches where we don't have constant tension, or, well, constant tension is mostly delivered with these winches, but where we have, for example, 2 suppliers that have different control systems and they don't work together. So in a way, it's also, from my point of view, I think also a safer system than the control system, because in control system, you always have to be sure that you set up the right values. But the bad thing is, of course, you need to have adapter, this adapter plate that is connected to the frame. And if you change the frame, maybe you also need to change the frame, the adapter plate, the plate that is connected to the jaws. It's also good to say that when the plate is in the jaws, it is impossible to unlock it. So the shape of the jaw tip is made in a way that it gets self-locked. So first you need to lift with the winch, and when we are lifting with the winch, we then again have the springs and the same story that we had with the first locking head, so that we make sure that whenever we lift, we can compress the springs and then unlock the jaws and release. Yeah, here on the right side, we just have the picture from the FAT where we have the plate locked. Unfortunately, I don't have photos of the real system. We were visiting the Japanese this vessel, and we have been with the service people on board, and the system works fine. So, but unfortunately, due to the rules, we are not allowed to take any photos in Japan. So it is everything that I have is what I'm showing here. That's everything from my side. It was 15 minutes.
Thank you, Harsen. Just a couple quick questions for the latching mechanism. Is that something that you guys manufactured, or you worked with the operator for them to manufacture the plate to go on their CTV?
Yeah, we worked together with the manufacturer in this case to manufacture the plate, and we have been discussing about some, I think 2 years ago, we have been discussing with Seabird to try to make a custom plate for their frames. So in this case, I don't know who was the manufacturer of the frame. It was going through the shipyard, so we made it based on some drawings that we received. But in general, for us, it's not a problem to make this plate and deliver it with the system.
Okay, thanks. Why don't we, I got ahead of myself. Why don't we save questions for you for the end of the session if there's time. So let's have Fred present next. So if you wouldn't mind unsharing your screen. Thank you. And then Fred, do you want to try sharing?
Sure thing. Okay, initiating share.
Okay, there it is.
Good.
Yep.
Okay. Yeah, so thanks for inviting me, Ethan. And nice talk, Harsen. Some interesting features there that some are shared by this system. So yeah, Ethan asked me to talk about the JSON LARS docking head, the specifics of the docking. Sorry, let me go to the beginning here. Okay, that looks like a slideshow, right?
Yep, you're good.
Okay, so yeah, so we're talking today. I'm Fred Denton, research engineer with the Jason Group. I integrated this system back in 2015. It's a combination of a wrap winch, the overall launch and recovery system, that is a combination of a wrap winch shown here on the left. Can you see my cursor? Can you see?
Yes, we can.
Yes,
Okay,
we
great,
can.
thanks. So that's the wrap winch there. And then this is the NPC crane. That's North Pacific Crane. And wrap winch, of course, is now part of Macgregor with Triplex, Harsen's company. So we had this wrap winch from a previous iteration that carried 681 cable. And in 2015, we undertook a conversion to a heavier lift system for the Jason ROV. The goal is to service the WHOI regional cabled array, which is out off of Seattle, off of the Pacific Northwest. So we're moving these packages shown here on the left, some that can be up to 4,000 pounds. So we have a now 11,000 pound ROV that is latching on to up to 4,000 pound packages. So 15,000 pound capacity for this system. So yeah, that's what drove the design. So because we are integrating two systems, a crane from North Pacific Crane and crane and docking head, which was built new, with our wrap winch, which was a conversion. We did this, in order to not have to throw out the wrap winch we already had. Because it was a conversion, we have a system where the operator has to do a lot of things in sequence in order to do a docking, in order to use the docking head and the latching of the docking head safely. We have a set of procedures and we've been following them and they work great. So I will get into those. Oh yeah, well, before I do, I'll just say that this is an 842 inch cable, 0.842 inch. It's got a 70,000 pound braking strength. We had this cable custom designed and built for this application. So that's what's on the winch drum, 5,000 meters of it. Yeah, so the LARS crane's got a 20-foot reach at Sea State 4, some of the main specs. And it can ship as one piece, which is handy considering how large it is. And it comes with this latching docking head that was designed by NPC. And then some mods were made by me to get it to work smoothly. So the winch, it's a key feature of it is that it has a constant tension mode. It's got that, as in there's a button on the control box that the crane operator has, the LARS operator. They're sitting on the crane when they operate the crane using the manual hydraulic controls. Crane's right behind me there, actually. So then we also have the joy box for the winch sitting at the same operator station. So they're operated as one LARS at one seat. So this is the sequence for a recovery. So starting with the vehicle in the water, I'll now walk through the steps. And as you can see, each step in blue, you have a winch command, and in black, you have a crane command. I'm going to move to the pictures here. So yeah, this is a close-up of the docking head. The latching goes on right here. You have air springs, and they, of course, come up as the vehicle hits this or kisses up against this this bottom piece of the docking head. And what stops the vehicle stops the winch from hauling in is the tension setting, the max tension torque setting of the winch. The winch is set to render at 16,000 pounds, as in stop turning, won't pull more than that. So that's how we prevent a two block scenario. So basically, yeah, you're pulling up. This bullet here shown here, that's on the top of the ROV. So that's pinned to the frame. So that barbed bullet there is pulled up through the center of the docking head to above the latches. There's two latch plates, hydraulically actuated, simple in out. Here's a close-up of that latch. It's got some features there to prevent it from unlocking. It's also got a counterbalance valve on the hydraulic rams to prevent them from moving unless commanded. So yes, and the cable termination is screwed into the top of this bullet. So the whole load path goes through this bullet. Okay, oops. Sorry, so there's step two is the operator drives in the latch plates. And step three of a dock, while holding the handle of the latch engage function on the docking head, the winch is lowered down manually onto the jaws of the winch, of the latch. At that point, you slack off the continue to pay out on the winch until you see some visual slack in the cable. We have three checks that we do to make sure that we're fully latched before starting to move the docking head. We're going to be checking for that slack catenary. The operator is going to be checking for a latch light, which is indicating that the two proc switches tied to the monitoring the latch plates, that they are closed. So as in, that's telling the operator that the latches are fully engaged. And the third thing, we have a camera. And so we get a call out from the control van telling the operator the latch visually confirmed. So that's how we get a good solid latch. At that point, we engage the constant tension mode of the winch, where it goes from manual stick control to an auto following constant tension mode. The setting of that constant tension mode is roughly 1,000 pounds out of the 15,000 pound load. It's a much smaller percentage. So you have a little bit of tension there to manage the cable and prevent slack. So that gives lots of overhead overhead and underhead really, as the crane then starts to knuckle in and move from overboarding position to the deck. The winch follows, and it's not perfect, so the winch that is, and it's responding to the change in the tension as the crane knuckles in or out. That 1,000-pound setting has worked well for us in maintaining lack of slack, maintaining a taut cable, and certainly not over tensioning the cable. So yeah, that is, yeah, well, I guess to finish up, you get to over the deck, over your spot where you want to drop off the Jason vehicle. And at that point, it's somewhat in reverse. The operator pushes that constant tension button again to deactivate it and bring back manual stick control of the winch. And at that point, the operator can haul in on the winch, and then it's going to go right up to the max tension that the winch can pull, 16,000 pounds. So that at that point, that's 1,000 pounds more than the weight of the vehicle. So the vehicle and package will come up off of, and then you're running this in reverse. So you come up to this, and then you can pull out your latches out of the way and lower the winch. So yeah, you have that feature where the latch plates cannot be opened up with the load hanging on the bullet, and yeah, the load of the winch, sorry, of the ROV hanging on the bullet. Yeah, I think let me get over to these elements of a safe, secure dock. Make sure I covered all of those. Yeah, the compliant mechanism is air springs. That's worked pretty well for us, like what you'd have on a suspension of a tractor trailer. And the pre-load pre-charge is actually 0 psi, just fully relaxed at 0, and then as it gets compressed, it comes up to providing some resistance, enough resistance to slow things down. Yeah, we went over the 3 latch indicators and winch torque limits, secure latch. Yep, that's all of it. So that's how our system works. Apologize, it's not the slickest sales pitch as what Harsen has there, but that gets our more manual way of doing things across to you guys.
We can improve that. No, but I like it. It's really, it looks simple. It's
yeah, it's
the
simple.
important thing is that it works.
Yes.
Okay.
Yeah, so, and I'll take it away, Ethan.
Thank you very much, Fred. That was an excellent presentation. I think definitely for the gearheads as far as the way these things work. So, so I just want to say one more thing, and then I'll open it up for questions. So this is really directed towards the operators that were, involved in the July meeting that have these hands-free systems on their ships. I think with any new type of system like this, there's going to be growing pains. I certainly went through it myself on Sekuliak. I'm not trying to dig into the vendors. I just think these systems are pretty one-off, and we have to find the right way for them to work with the platform and the package that we're trying to use. So the big takeaways, I think, from Harsen's and Fred's talks are the latch control systems. I see a lack of those on the LARS that we currently have on the newer ships. That is an alternative to solely relying on the tension member to provide the high tension needed to keep that thing sucked up into the docking head. And there's some other fail safes as well, like proximity sensors and the way that the control software is used. So I hope people are getting some ideas as far as solutions go. With that, I will open it up to questions or comments from the audience. Thank you.
Fred, can you stop sharing screens so we can see
Oh.
faces?
Sorry.
That's right. Or printed names.
Really? Oh, sorry. Go ahead, Max. You have your hand up.
Yeah, I just thank you very much for these presentations. It's we've been talking about both of these principles and resolving the issue, some of the issues that we've seen, constant tension and latching. Just out of interest, a question for the Jason group: how far off the deck is Jason when you remove the latches on a recovery?
That's a good question. That is a few inches.
Great. Well, there you have it. So you're not coming down from 3 or 4 or 5 feet, like.
No, yeah, right. If anything were to go awry, we would want it not to drop too far. Yep.
Of course.
But of course, at the same time, you can't be on the deck, so we go down close.
Yep. And then a question for Harsen was, especially with the latched system, when you have several moving parts. What are your maintenance recommendations? That's something that we noticed that sometimes, when the system works well, people tend to get a little complacent and forget to lubricate stuff and check everything every time that the latches are moving parts are properly working. What are the materials and your maintenance protocols? I mean, not to go into too much details.
Yeah, for all these, let's say, small parts, we have kind of a rule to design the system with composite bearings and stuff that doesn't need lubrication, because the loads are small, and so it's in principle on the docking head you have seen there is I think there is not one single grease nipple on these parts. Also not for the top part where we have the big springs. We have on Sikuliak, I think we have that, but we have changed that to composite bearing called D-Glide from DuPont. I think it's those that we are using, and also we are using those for our telescopic booms, and we are very happy, and the clients are very happy. So we try to reduce also this maintenance part. And the springs are made of sea-resistant stainless steel. So also same goes for the bolts, for the pins. So it's really not much of that needed. What I see as a problem here is that maybe when we have a low temperature operation and these small cylinders with small hoses, and there is no way for some part of the oil to go back to the system and get heat up. So then we would need to provide additional heat for that, and it will make the system a bit more complex, but yeah, it's all in all, I think we should try to put more of these out in the market.
Yeah, thank you. The low temperature won't be an issue here in Hawaii.
Yeah, of course, but it will on the Sikuliak. They have snow.
Yeah.
Yeah, I installed the D-Glide bearings a couple years ago, and as you mentioned, those don't need to be lubricated. There's no way to. There's no way to.
Yeah, I remember we replaced them. Yeah. Yeah. Okay. Yes.
Yeah, and then for the stainless parts, I just dry lube them with a product called McLube. It's a sailing product, and that works pretty well for the stainless parts. Okay, Matt, go ahead.
Yeah, I was just I was interested in that from Harsen, the docking head that moves off from the shiv. Is that what you have on Sikuliak now, or is that just for the RCRVs?
Yeah, on
So
Sikuliak, we have it on Sikuliak, but it's not the same.
Okay.
The cylinders that we have on Sikuliak is for actually for manually pointing the docking head towards the rope direction. And the one that we have on RCRV is to remove the docking head out of the picture when we are in the cast, so the rope is free to go anywhere.
Yeah, no, that's a cool. It's a cool idea. I'm interested to see how that works out in real life. We've recently so I work at Scripps, where we have the Allied crane with the marquee winch LARS system, and it was designed with towing and things like that in mind, but we've had issues sometimes with how that wire comes in contact with different parts of the LARS system, and I'm wondering how.
Yeah, we
how
have
it
problems also.
Pretty smooth, yeah. So
Yeah.
that's cool. I was just curious if that's actually been put to sea yet, or if that's still in.
It is. We have one in Germany on a vessel called Atair. It was 3 years ago. We delivered that, and then I think for the RVS Nuina, the new Polar Arse breaker from Australia, also there. It's just being actually delivered to the client, so it's not much of that. But in China, we have delivered, I think, 5, and all of them are working pretty nice.
They work pretty good, and in rough weather, it hangs out of the way.
Yeah, they're hanging because docking head is made of aluminium, so it's
light.
It's very light.
Oh, nice. That's cool. Yeah, that's interesting. Thank you.
I will say for the Sikuliak docking head, because it was built for side towing, it's got all that play in the cylinders in the docking head, and we don't use it for side towing. We never will. It's solely for our CTD, and on a waves cruise, it scared the shit out of me how close the CTD came to hitting the door frame every time. So because it moves around like that. So I actually added counterbalance valves to the cylinders on the docking head to prevent it from swinging around. I'd rather not have it swing around and not have the feature. And I think that protects the CTD a lot more because the docking head's not swinging. But that's for our application because we're stuck with the docking head being integral to the overboarding shiv.
Do you guys ever get asked to do Toyo CTDs?
We do, but it's pretty rare.
Yeah, that's where we run it, and most recently, I think it was a combination of weather and crab angle to the survey line. It just happened to find exactly where it didn't work. Whereas I've done Toyos with our system, and it's kind of rough on the roller shivs, fore-after roller shivs, but those almost become consumable on a long Toyo cruise. But having more freedom in our docking head is not aluminum, so it's very heavy, and so as you start towing, you put a lot of kind of strain on things that maybe shouldn't have it.
Yep, and that's not to say we can't tow anymore off the docking head. It just means that rather than allow that play in the hydraulic cylinders, it just means the operator has to operate those cylinders. They have to pressurize those cylinders.
We do have we have damper cylinders on there, so you're in theory, I haven't seen it work quite as advertised, but in theory you should be able to turn the damper up and it's very stiff, and turn the damper down and it moves a little bit, but there's still a lot of weight to that.
So by adding the counterbalance valves, I eliminated that dampening feature, but you can still exercise the cylinder. You can still pressurize the cylinders and move the docking head. So,
but can you turn them off?
I mean, I can turn the valves all the way down, so there's no pressure on them. So
yeah, but the thing with the RCRV is that we have a overcenter valve with an electric power, so we can actually turn the cylinder completely off and just make it swing, and we can turn it on and control it and also keep it in place.
Well, you didn't give us that cool feature, Harsen.
Yeah, but the Seculiac was the first one, so.
Yeah, I know. Let's
Tom,
move
he's
on.
up, Tom.
Alex has a question. Go ahead.
This will be quick here. This is for Fred. I'm wondering how you deal with your load cells, and if you calibrate them every time you put the thing on the boat, you water bag it, or how do you deal with that?
Yeah, good question. Yeah, so we have the load pin in the level wind of the wrap winch. So it's a 90-degree level wind, a constant 90 degrees on it. And we don't calibrate it every cruise, but we calibrate it about once a year. We do the calibration at the same time that we are setting our termination, the mechanical termination of the cable. So we're going to have a calibrated ship's load cell dynamometer tied to a hard point on the ship. So we're just pulling against the ship, and that's what we use.
Okay, right on, thanks.
Oh, and it's also, in a sense, when you're doing that pull, we're just pulling up to 100% of that, the torque limit of the winch. And so that's sort of a built-in master. I see no reason why that would drift. So that's what we're pulling up to, and then so we sort of have two sources, but we're using the load cell on the shackle.
Got it.
Okay. Are there any other questions? Jules says we have until 10:55, so we got a couple more minutes.
I'm zoomed out, man. I need a break.
Ethan, it's Marshall. I'd like to know. I'd like to know if there are any specific plans by operators with current LARS systems to have a regular dummy load testing procedure in place.
I'm going to let Jim Hollick answer that.
Write a proposal.
My 2 cents, Marshall, is that, based on the meeting in July and then hopefully the discussion we're having today, this will only continue to blossom into what Brandy mentioned earlier as, we more or less have kind of an advisory group for the fleet for these types of systems. And those kinds of recommendations or actions could come out of that group. At least that's the way I would envision it. And I see Jim nodding his head that I think he's supportive of the idea. So nothing's going to happen overnight, but I think some of us are interested in having this type of discussion carry into something bigger for the fleet. So stay tuned. Andrew.
Yeah. Oh, just real quick on the same topic is, I forgot to mention it when we were talking about the report, but at least one institution has already implemented a standard practice of starting with their crews with the dummy load to make sure it works.
Yep, that's us. Good. I don't have to waste any more time. Thank you.
All right, one more question.
Session.
Andrew.
Yeah, that was my question. I was hoping you could provide some more details on your plans for that committee. Would it be just a temporary advisory committee to solve a specific problem, or are you thinking long term, or you don't know yet?
Let us meet again. We have a bunch of people, and it was a really big meeting, very good meeting actually. We're going to get the minutes out, the summary out, and then we'll meet again and we'll decide. I'm not sure. I mean, we have a lot of committees, but this is a really good one and a great session, by the way. I think this is long overdue to get down to the essence of these things.
Yeah, and we have a lot of great technical engineering folks in the fleet, I think, who have brought these kinds of solutions to bear to the kinds of issues that we've been discussing. So that's why we have these venues, right?
Correct. So Ethan, do you still have your chart that you set before every deployment based on history?
Yeah. So again, you know, our system on Sequoiac is kind of a older generation system, and we've chosen to run it a little differently than I think the vendor intended us to. And so, yeah, we provide lookup tables to our operators, just kind of emphasizing what Fred mentioned about those kinds of step-by-step procedures and sequences. That's what it's all about for these types of integrated systems, is the ability for the operator to go step-by-step through a procedure, have positive controls telling them that they can move on to the next thing, and that they get that feedback as far as, you know, this is the state of my package, this is what it weighs, this is what I need to do to my system to have a safe recovery or launch.
Now, we had too many lost packages in the past few years, but this is why we're addressing this. And according to Marshall, they're going out to get the one they've lost. So fingers are crossed. Good luck.
I am sorry to cut an active conversation short, but we do need to queue up the next session of instrumentation. If you want to continue the discussion, there is a community topic for launch and recovery systems. And I think you'll be hearing more about this as the report and subsequent meetings continue. So thank you. And thank you, Ethan, for putting this together. Harsen,
Yeah,
Fred, thank you very much.
Very good
thank you,
session.
Fred. Thank you, Harsen.